Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our P3. This video is going to focus on a physics demo style project. This may be a little bit different from your current P3, but the fundamentals are going to be the same. This video assumes that you have done a couple of things, including having a working environment to compile code in, and have also watched some of the earlier videos focusing on the fundamentals demo, as well as having completed your P2 project. So you'll notice here that I have a copy of the instructions, as well as a setup, samples, and then my main template. We'll also be taking a look at a chart that I've created with the switches and a few other things as we go along. So I encourage you to have the PowerPoint open that I've provided with the equations for the physics demo. So to begin with, let's take a look at our P3. And so as you'll note, it's very similar to the P2, but with the big difference being is that we want to be able to change how we get the information from the user. And so in this video, what we're going to do is we're going to focus on the switches that we are going to pass from the command line to the executable to control the behavior of our application. First and foremost, you should notice that we want to be able to provide to the user a set of tier 1 switches, particularly the help mode, both implicit and explicit. If it's explicit, then basically the user will have provided a /H. And then we also want to follow this up with the 1D, 2D, and beam options, which once again came from our earlier P2 project. The difference being, though, is how we are going to collect the information. And this is where our second tier switches come into play. And so for each of the modes, the 1D, 2D, and beam, we also want to provide them with an additional switch for either interactive or parametric mode. The interactive mode will be identified by using a scanf, or rather a printf and a scanf, to prompt the user for a particular piece of information. The parametric mode will simply pull that information from an additional command line argument. And so to help you appreciate this a little bit better, I've set up this table. And the idea here is that in all of these examples, the name of our executable, in this case, p3.exe, will be our 0th argument. If you recall, in C, indexing in an array starts at 0. And so in all of these examples, our argv square brackets 0 will be our executable name. You'll also note that that means that that is also results in an argument count of 1 if that is the only thing that is provided by the user. If the user provides 2 arguments, and particularly if that second argument, or argv square brackets 1, is a question mark, then we would like for the help to be called, and specifically a /question mark. If they provide a /H, we would also like to have the help being called. And then we can proceed to the other examples of /1D, /2D, and /beam, as well as the option in which they pass something to us that is effectively nonsense. If they pass nonsense, once again, we would like to get an implicit call to help. Now, as we said in the instructions, if the user provides /1D, we then have to provide additional information, or in this case, an additional switch of either /I for interactive and /P for parametric. We're going to focus first on the /I. The idea then is it would make some call in our program that would print to the console or print to the user some instructions to enter in the case of the 1D example, the initial height. In the /P option, the user would need to provide an additional argument for a total of 4 arguments, in which case they would have /1D, /P, and then 100. Now you notice over in the examples that I provided at the right, I'm not including the p3.exe because once again, that's assumed to be there in all of these examples. Likewise, for the 2D, then user would provide /2D/I for interactive mode, at which point our executable would have a printf and a scanf to collect the two pieces of information, the vinit and the theta. And if the user is interested in calling our executable in the 2D mode parametrically, then we have to provide those additional two pieces of information on the command line for a total of 5 arguments. The vinit would be argv square brackets 3, and the theta would be argv square brackets 4. Lastly, for the beam option, we could provide either /beam/I, which would mean, once again, it's interactive, and there would be 3 scanfs and printfs to collect the additional information. Or if the user was interested in running it parametrically, then they would provide /beam/P, followed by 3 additional pieces of information on the command line. And as you can see, the example on the right, similar to the one that we have done in P2, and that they would just provide /beam/P, followed by 100 for the total load, 10 for the length of the beam, and 5 for the location of the load. And then lastly, if the user enters in anything that doesn't match any of the previous options, effectively it's nonsense, we would want to have an implicit call for help. So once again, the purpose of this video is just to make sure that we understand the instructions and how they translate to the switch combinations. What I encourage you to do is to get a copy of this table and use it to construct your help, which is actually the first step in what we're going to be doing in our next video. If you can construct your help and all of the switch combinations, constructing the if statement to be able to triage those switches will be significantly easier. So if anything, just keep a copy of this around for the following videos. As always, if you have any questions or comments, don't hesitate to ask, and thank you for watching.